All right, in this video, we're going to take a look at determining the necessary sample size that you would need for to be within a certain amount of the population mean. So our margin of error, which we'll call E for error, for a population mean has been given as our critical z value here, z sub alpha over 2, times our standard deviation divided by the square root of our sample size. And if we solve this equation for n, so divide both sides by z alpha over 2, we get proportion here. We can cross multiply and get e times the square root of n equals sigma times z sub alpha over 2. Divide both sides by e to get the square root of n equals this right side divided by e. And then to get n by itself, if it's being square rooted, we want to square both sides. This will give us our population or our sample size we need to be within a certain margin of error of the population mean. So let's take a look at using that in example 5 here. So example 5, how large of a sample size should we take if we want to create a 95% confidence interval that is within 2 cents per gallon of the mean cost of gasoline? Assuming the standard deviation is 12 cents a gallon. So like we did in, I think it was example 1 back a couple videos ago. All right, so we have a formula. We have our standard deviation is 12. We have our 95% confidence interval, so we can put that 1.96 here for z sub alpha over 2. And by the way, it's not going to matter if we put positive or negative 1.96 because we're going to end up squaring it anyway. And when we square positive 1.96, it's the same answer as squaring negative 1.96. And our margin of error here is 2 cents per gallon. So that's the error value that goes in our denominator. So putting those values in and again, just calculating it all out. This is just basic calculator work at this point. We get 138.2976. So we need a sample size of 138.2976, at least 138.2976. Now, we can't take 0.2976 or 0.3 or any decimal value of an observation. So whenever we get a decimal for our sample size, we just round it up to the next highest integer, which in this case is 139. So if we take a sample of at least 139 gasoline prices, then we should be able to get a 95% confidence interval that is within 2 cents per gallon of the mean cost of gasoline, so population mean. All right, for proportions, it's the same principle. We're going to solve this equation, this margin of error equation here for n. And without going through all the calculations, you have to divide, square, multiply, and divide and all that. We get n as the probability of success times the probability of failure times, pardon me, critical value over the margin of error, that value squared. So, all right, example 6, a recent poll shows that 301 out of 578 voters favor renovating a local park. How large of a sample must we take in order to create a 95% confidence interval that is within 4% of the population proportion? So we did look at, in our last video, I believe we used 98%. I can't remember off the top of my head. But our margin of error was, I think, lower than 4%. So I don't really remember off the top of my head, but our probability of success, 301 out of 578.521. So plugging in the values, we have 0.521 times probability of failure, 0.479. All that times our critical value for 95% is 1.96 over 4% as a decimal is 0.04, and we're going to square that ratio. We get about 599.19, which bumps it up to 600. So we would need a sample size of at least 600. Excuse me. All right, so that about does it for this video. Thank you for watching. I'll see you next time.